Good evening, everyone. So now, our focus shifts to the realm of data analysis and classification techniques. These presentations showcase the versatility of machine intelligence in handling diverse data sets, from the identification of promising customers to enhancing security in blockchain-based EHR retrieval. The papers on display promise to illuminate the intricate landscape of data-driven decision-making. The session chair for this session would be Dr. Amrita Priyam. Dr. Amrita Priyam is an associate professor in the Department of Computer Science and Engineering at BIT Lalpur, Ranchi campus. She has done MTech in computer science and PhD in engineering. Her area of interest lies in object-oriented modeling and design, artificial intelligence, software engineering, decision models, and optimization techniques. She has credit for publishing papers in various journals. Ma'am has been a reviewer of many papers. She has also been a member of International Association of Engineers and life member of Indian Society for Technical Education. I request ma'am to kindly continue with the proceedings as the session chair.
Thanks. We can continue. The first speaker can come and present.
The first speaker for the theme Data Analysis and Classification Techniques would present the paper under the title Performance Analysis of Machine Learning Algorithms for Data Classification.
Good afternoon, everyone. Thank you all for being here. First of all, I would like to thank our Almighty God for helping me to prepare this research work. Today, I am going to present this paper on the topic Performance Analysis of Machine Learning Algorithms for Data Classification. I want to share some key informations that you all need to know. The primary goal of this research work is to offer a comparative performance analysis of machine learning techniques. We have used three algorithms: logistic regression, decision tree, and artificial neural network based on two data sets, driving data set and raising data sets. These are taken from UCI machine repository. And we have used the principal component analysis, PCA techniques, to decrease the attributes of the database, because driving data sets, that is a large sample that has large samples, 13,611, and raising data set is also having 900 samples. The performance analysis of these three classifiers was compared using parameters such as size of the data set, attributes of the data set, and number of classes, and class imbalance, and missing values, as well as some performance matrices, accuracy, precision, recall, FL score. According to our findings, the artificial neural network classifier gives the better result based on driving data set on resins. With accuracy, we have found 89%. The results also show that logistic regression and artificial neural network that gives identical values, whereas decision tree that performs the lowest. The main contribution of this research work are as follows. The data set first we have considered that is normalized based on, we have used Z-score, and after that we have reduced number of attributes using principal component analysis. Then we apply machine learning techniques such as already said that logistic regression, decision tree and artificial neural network. In these machine learning approaches, performance measures like accuracy, precision, recall and FL scores are calculated and compared. And this is the workflow diagram of the research paper. First, the pre-processing stage, in that normalization is done and PCA is applied. And we have split the data set into training and testing data, 80% training data and testing data 20%. And after that, we have applied machine learning techniques and the results are compared. These are some related work that is summarized. In the second one, according to S. Krishnan, they have used machine learning algorithms, random forest, XGBoost and CatBoost. The evaluation parameter matrix, they have used accuracy and confusion matrix. And they found that CatBoost machine learning techniques gives the best result among 30 algorithms they have applied on. And in their paper, they have shown only 3 techniques. And Kokule and M also, they have used algorithms, multiple linear perceptron, support vector machine, KNN and decision tree. And the matrix was accuracy, and SVM gives the highest accuracy. And as we can see, SVM that gives better results. In the third one, in Slonsky's, they used many techniques, and the performance matrix were accuracies and confusion matrix, and the accuracies belongs to the range 88.35 to 93.61. And these are also some related work. In our work, we have used these techniques, some supervised learning and some unsupervised learning techniques we have used. And for data extraction, we have used principal component analysis. And for normalization, we have used Z-score. Logistic regression, instead of simple linear regression, instead of taking straight line, we have used S-shaped logistic function that classifies the 2 classes with values 0 and 1. In artificial neural network, we have used the second technique, that is a tool for solving linear and adaptation problems. Perceptron, that is a basic neural network having one neural in the output layer for making decisions. And between input layer and output layer, L, T and T, where L input layer contains L and the hidden layers are there that contains T, and the output layer contains 1 L number of neurons. And the final layer, that is the output layer, which evaluates the previous layer's activation values to predict output variables. And this is the neural network topology. And the sigmoid function we have used in equation number 1, where alpha is the learning rate and I is the net activation of neuron. The third technique, decision tree. For constructing decision tree, for choosing best splitting attribute, we have used entropy and information gain. So information entropy must be calculated. So we have used this equation number 2 for calculating entropy, and for calculating information gain, we have used equation number 3. And for normalization, for normally distributed, the values, all the values must be normally distributed. So in this research work, we have used this Z is equals to x minus mu sigma, this equation, where mu is 0 and sigma standard deviation is 1, and the value ranges from -1 to 1. Principal component analysis, in this, that is a popular linear dimensionality reduction technique, because as I said that this drive-in data set, this has a huge samples, 13,611 attributes, and 16 attributes and 13,611 samples with 7 classes. So it is needed to reduce dimensions. So with PCA we have converted it into 2 components. And the aim of this research work is to decrease the attributes using PCA. And this is the dataset description. And these are the number of instances in each class for driving dataset. As we can say, there are 7 classes.
What's the name of the classes?
1 minute, ma'am.
अच्छा 2 minutes left.
Ma'am, these are Barbunia. This is overlapping, but Barbunia, Bombay, Cali, Horos, Darmashine, and Sira. Number of instances in each class for aging dataset. These are the 2 classes in this, Kesimen and Destiny. So 900 samples in this. This is a balanced dataset. 450 and each. But in the previous one, we can say this is an imbalanced dataset. So one dataset I have chosen imbalanced and one is balanced dataset. The confusion matrix is used. So based on this true positive, false negative, false positive and true negative, these are the performance matrices, accuracy, precision, recall and F1 score. We have been used these parameters. And these are the results for our work. For resin dataset which has 900 samples, in this we can see artificial neural network that gives 0.89% or 0.889, and in driving dataset again in artificial neural network it gives 0.87. This is the table. In that we can see logistic regression and artificial neural network. These are some identical values, and decision tree that gives the lowest accuracy. These are the confusion matrix we have drawn for all the 3 techniques: logistic regression, decision tree, and neural network. For resin dataset also this is the confusion matrix. And in conclusion, in this research work we have used 2 datasets, drivins and resins, having 16 attributes and 7 classes and 13,611 samples. And in resin dataset, it has 7 attributes, 2 classes with 900 instances. The matrix of performance such as accuracy, precision, recall, F1 score are calculated, and the performance of these 3 classifiers have been compared. The performance analysis of 3 techniques are shown in the table 1, and the results reveal that artificial neural network classifier gives the best accuracy, 89% among all the 3 algorithms. Also the results shown in table 3, the performance of logistic regression artificial neural network is the most similar, and decision tree performs the most among all the classifiers. These are some future enhancement we are working on this. Further, one can work with a driving dataset for classifying multiple attributes so that no attribute will be losing, and samplings can be done to each sample for balancing dataset to get better results. There are many balancing techniques like for oversampling, for undersampling, for SMOT, and one of the technique SMOT also we have been used in another paper. Also, one can use other feature selection methods, like for an example correlation, that has not been used because we have used principal component analysis, so correlation is not used. So another correlation also can be used to select most suitable features for finding better accuracy. And after that, many advanced Ansible techniques like cat boost, XG boost, these can also be used for getting good results. And these are the references slides. Thank you. Let me take the opportunity to thank our guide, my guide, Dr. Jayapal ma'am and Dr. Devjani ma'am, for helping me to prepare this paper. Once again, I thank all of you. Thank you.
Any question? Any question you can ask?
Let me hear.
Any question?
So we proceed with the second paper for the second session today. The paper under the title "The Identification of the Business's Most Promising Customers" is to be presented now. Sir.
Good afternoon. Today we will talk about the identification of a business's most promising customers. The objective: the most promising customers are characterized by their consistent high-value transactions, frequent utilization of the provided facilities, and recent active engagement. Such customers become prime targets for tailored marketing initiatives, including special offers, discounts, and other enticing perks designed to mitigate customer attrition. Now, our objective is the detrimental impact of customer churn, marked by the loss of revenue, underscores the urgency of this pursuit. Our study is dedicated to identify the most promising customers through the application of a normalized RFM, recency, frequency, and monitoring model.
There are two objectives.
Sorry. Introduction. Modern businesses routinely collect and store daily purchase data, a valuable resource for generating insightful reports. These reports in turn empower businesses to discern their most promising customers. With this knowledge, companies can craft tailor-made marketing strategies designed to engage these high-value patrons based on their shopping patterns. Now, by delving into the purchase data of their clientele, businesses gain a deeper understanding of buying behaviors and preferences, thereby facilitating the target provision of discounts and other incentives to foster customer loyalty. There is a saying that creating new customers base is 5 times more costly than maintaining the trust of existing customers. So we focus on maintaining the trust of potential customers that are most promising for the businesses. In today's business landscape, combating customer churn is of paramount importance. This phenomena can have adverse repercussions, causing customers to defect to competitors due to factors such as service quality, pricing, or personal concerns. One of the most straightforward approaches for identifying the most promising customer entails leveraging individual customers' RFM scores, recency, frequency, and monitoring scores. These RFM scores offer a means to categorize customers into groups with similar purchasing behaviors. This enables businesses to distinguish their profitable customers and pinpoint those at the risk of churning. Now, our goal is the research proposes a model for identifying the most profitable and loyal customers using the normalized recency, frequency, and monitoring strategy. Now, there is a hypothesis that the NFRM scores facilitates the creation of a customer clusters based on shared shopping patterns within a business. Now, our objective is to discern and target the most promising customers within the business with the intention of preventing their attrition. Now, the basic steps to identify the most promising customers: a comprehensive RFM must be collected using the daily transaction data. We will take the daily transaction data and extract the recency, means how recent the customer made a purchase, frequency, how often the customer makes a purchase, and monitoring. The total amount of purchase that a customer does is recorded using this daily transaction data. Employing this process enables us to pinpoint both the customers of utmost value to the business and those at a higher risk of churning. Using customers' purchasing behaviors as a basis, we can compute the RFM score of each customer who has engaged with the business, signifying a purchase. Now, the basic method for calculating the recency score: we first calculate the value of R. The recency score R of a customer is determined by calculating the time difference between the most recent purchase and the date of that purchase. From the recency scores, we derive both the minimum and maximum values. We calculate the recency score for all customers, then we find the minimum, means R minimum and R maximum, and then we normalize it to a value RT equals R minus R min, R max minus R min.
What is date of that purchase and what is recent purchase?
The recent purchase,
And the
this
date
this
of-
one.
The first line. between their most recent purchase and the date of that purchase.
Between the most.
By calculating
Ha.
the time difference between their most recent purchase and the date of that purchase.
Most recent purchase and the date of that purchase means R minus R min or R max minus R min.
Both.
Okay. Now suppose a customer buys 20 days, means there are two customers. First one buys 20 days earlier and second one buys 0, means the most recent one. So RT equals, this one is 20, 20 minus 0, and R max is again 20, 20 minus 0. So this is 1. So the most, means the oldest customer, that will have the highest value. So we subtract it from 1. R equals 1 minus RT. So,
Renormalize. This is renormalized.
now similarly we calculate the monetary score by aggregating the total purchases made by each customer as reflected in their purchase history. Likewise, we proceed to normalize the monetary score. Similarly, we normalize the monetary scores, then we normalize the frequency scores. Now, we assign weights to the variables XR, XM and XF depending on the business owner's preferences. Suppose a business wants to give a higher preference to a monetary score, then we can give a higher value to XM. If they want to give a higher importance to the customers that have higher frequency of data, then they can give a higher score to the value of XF. So XR is for recency, XF is for monetary, and XF is for the frequency. And there is this constraint, XR plus XM plus XF equals 1. So this is based on customers, means the business owner's perspective, what he considers to be best for the business. Now we calculate the RFM score as XR into M. M is as given by the XR into R, XF into F and XM into M, as given by this F, M, R. Now we propose an algorithm for identification of most promising customers. Calculate the recency, frequency, monetary score for all customers. Calculate R min, R max, F min, F max, M min and M max. Normalize the values RFM to get RFM as given by the equations 1, 2, 3 and 4. And initialize the values of XRX, FR and WR. Calculate RFM scores for each customer as given by the equation 5 and 6. Apply K-means clustering to find the most promising customers of the business. So we apply K-means clustering to find out the most promising customers of the
2
business.
minutes left.
Okay. Now there is this online detailed data set. It contains 4372 rows and 3685 columns. During the algorithm execution, outliers were removed from by applying the K-means clustering. We found certain outliers that caused the algorithm to misinterpret these outliers as clusters. So we eliminated these outliers. Now the refined data set consisted of 4369 rows and 3685 columns. This is the hardware and software that we use for the. This is the segmentation of customers. And using the elbow method, we find that the optimal number of clusters is 3. We need to find 3 clusters. So we use K-means to cluster the entire data set into 3 clusters, cluster 0, cluster 1 and cluster 2. It is evident that cluster 0 boasts the highest average NFRFM score, comprising a total of 1446 customers. So the top one, cluster 0, is the most promising cluster of customers. This cluster represents a business's most promising customers, and it is an ideal target for focused marketing efforts aimed at nurturing their loyalty to the business. Now, conclusion, we employ normalized RFM score in combination with K-means clustering to achieve this objective. This approach allows us to identify the most promising customers and detect those who may be on the brink of churning. Okay. Thank you.
Any questions? Sir.
Thank you.
Thank you, sir. Now I would like to invite the presenter for our next paper, which is under the title Classification of Land Cover Image with Spectral Signature in Machine Learning. Good afternoon, madam. Good afternoon, all the fellow participants. Madam.
Today's my topic is classification of land cover image with spectral signature in machine learning. Under the guidance of Dr. Partha Paul, Associate Professor Sola Pilla University, and Dr. Neeraj Kumar Sharma, Jharkhand Space Application Center, Scientist, Jharkhand Space Application Center. I'll be talking on these topics, the abstract of my research work, introduction. The contents of my topic is the contents of my topic is abstract, the introduction, the literature survey, the methodology that I have used in this result and discussion, and there are few snapshots of my work, and lastly the references. Abstract. Here I have used the raster image obtained from the satellite data, and this raster image, my main thrust area is on the land cover. That is how the land consists of different landform, water body, agriculture part, the vegetation, the field, the built up human settlement, and how these will be treated by main thrust area is on the spectral reflectance. I have used spectral reflectance, and whether they will be classifying the different landforms or not. So the machine learning, it is the tool which will be doing the automatic classification of the raster data, which I got in a monochromatic form, and it is classified in different forms. We'll see how I have done. Now the spectral reflectance depends upon the wavelength, because sunlight falls on each landform. Its behavior is different with, and this is reflected by the wavelength. They either they incident on upon it or they radiate it, and this has been plotted with the help of a tool, and with the term used is a spectral signature. Spectral signature is the point of equal pixel similarity in the pixel wavelength. And the literary work that I have gone through is by A.M. Abdi. He has worked on land cover and land use, used support vector machine, the machine learning, of course, random forest, by using the Sentinel-2 data. This is the data provided by the European Satellite Agency, that is the Copernicus data. And I found out that they have done a lot of machine learning algorithms, these random forest and support vector machine. D.K. Gupta, S. Prasad, and P.K. Srivastava, they have also worked on the remote sensing of how the data behaves on the different Earth observatories, and how they are studied on different observations. R.K. Singh has worked on machine learning using the Landsat data provided by the US Satellite Agency, and they have used the maximum likelihood, minimum distances, between the pixel points because we get it in raster, so all work will be on the pixel points. S. Kumar and Shwetak and Kejan, they have used the spectral signature of land cover and they have basically worked on the Indian satellite agencies. And here they have used the multi-temporal data and multispectral imaging. I got the data from the US agency, that is the Sentinel-2A type. In this, my present work, I have used the QGIS software 3.28, and from this I got the Sentinel-2 data. They provided me a raster data. The raster data made up of many bands. I would like to go to the next slide here. This I got in a raster form, the monochromatic image, and towards the left side and index, I got the different layers. Though it is showing as a single image, but it is made up of so many bands, and all the bands have been clicked. You see, starting from BO2, BO3, BO4 up to BO12. Some of the data like BO9 or 10 are not there. So whatever was reflectant, these are shown. And in the lowermost point, I have shown what are the different, each band has its own wavelength and they have their color. So they will absorb the color or reflect the color blue, green, red, near infrared 2 and short wave infrared. So I got this image and this is the methodology that I have started. So I got this raster image. Then I had to do a pre-processing. Means it takes out all the reflectance, the effect of sunlight. Then I got the reflectance image and then I put some data for training and got the classification. That is, classification algorithm was the minimum distance algorithm. And then I got a classified image and then finally I used the spectral signature applied on it. I got a spectral response curve. So after I got this image, this is the snapshot. This is the background. You can see here is the training part, and this training I had to train on the raster image. I picked up some of the areas, and I said this appears like a vegetation. So I gave my own color like green. If I got a water body, there was a water body. There is a water body. It is a black. Because the water body is absorbed, the entire light was absorbed, so it appears black. It is a lake. I think it is near Getalsu Dam, near BIT. So I put it a blue color, and so it was the water was blue. Yes, ma'am. Okay. So this was the what I got as output, and on the front image, the image that is showing me the reflectance, that is the spectral reflectance. It classified the image automatically. And the different banding that you see is for water, blue is for water, then vegetation, then built up, and so on. So these are the snapshot, the final snapshot. I got it using the QGIS software, and it did it. This is the output for the vegetation for plantation. The major class was vegetation, subclass I took for plantation because there are many plantations. And the second one was vegetation and field. These are the various wavelength. The output was generated automatically by the machine learning algorithm. These are the various bands, and here is we are getting the spectral bands with different wavelengths. From the given data, that was automatically generated, I plotted it in a Python, and I got it that the blue color was for plant, and the building has got the highest spectral reflectance because they use all this. Then the open field, it reflected out more of sunlight. Then there was a road, the green one was road, all the colors were picked up automatically, and finally the plant has got lesser spectral reflectance. These are the references. I've gone through these references. And there are not many works to be done. I have not used the accuracy assessment. Had I got a previous data, and from there I would have calculated, or of rainy season or any different season, that would have been a better answer. Thank you.
Thank you.
The next paper to be presented is Accident Black Spot Identification based on classical and computational intelligence methods.
Refresh. Refresh. First. अच्छा ठीक 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 ओपन कर दो प्रेजेंटेशन ऑलरेडी है 134.
Thank you. Without mic or with mic?
Sir, audible without mic.
I think audible without mic.
Yes.
That is better. Okay. Good afternoon, everybody. Today I am going to present on the topic. I am Dr. Ambika Sarkar, Assistant Professor, Department of CSE, DIT Nagpur Center. And today I am going to present on the topic that is accident black spot identification based on classical and computational intelligence methods. Every year, 1.3 million people die in road accident. As per the, you can see here, it's a report published by World Health Organization in the year of 2009 and cited in the Global Status Report. And as per this report, almost every year, 1.3 million people die in road accident, and over 90% of world fatalities on the roads happen in the countries with more low or and the middle income groups. And additionally, many people are disabled due to their serious and incurable injuries. Globally, traffic scenario has experienced a vast change over the years. As the volume of traffic on urban road have increased leaps and bounds. The increase has also marked on the increase in the number of road accident that is fatal. Sometimes it's fatal, sometimes it's non-fatal. India is a home of 1.4 billion people, and an occurrence of road traffic injuries is also the leading cause of death in these countries. And you can see in this report, road traffic injuries in the year of 2004 that holds the 9th position. That was the 9th position. But it is anticipated that by the year of 2030, it will be the 5th leading cause of death in the world. And for this research, I have chosen Kolkata metropolis in India as my study area. Basically, I have selected few roads in that area. Kolkata, basically the city of Kolkata consists of numerous road networks in which a large number of accidents have been recorded so far. And road traffic accident data on Kolkata basically suggests the situation is far away from being safe for many of the roads of Kolkata. The resultant of which is increasing the loss of lives and the loss of properties. So the losses are increasing day by day if we are not taking the proper precautionary measure. And this safety measure can be made by employing some proper methods, techniques, model through the extensive research and the survey. So that's why I have employed a model. I have developed a model
accident black spot identification model. So first, what is accident black spot? Basically, it refers. It is not a spot. It is not a just only a point. Basically, it refers to the sites or the location of road where accidents frequently happen. And basically, this data has been recorded. Basically, the span of 3 years, preferably it's a 5 years data. And to make roads safer, it is much more important to identify the right location, right site, right segment for the safety improvement. My aim of my research basically to develop a mechanism for identifying the accident black spot using classical and computational method. Here I have used two classical method. One is accident severity and another is the accident frequency method. These are the classical method, and already it's a small part of my research. Basically, the extensive part of my research I have applied the ANN model, artificial neural network, as a computational intelligence method, and that data I have used for the accident black spot identification model. And to test the methodology for the selected urban roads, basically few urban roads of Kolkata. Obviously, Kolkata is a big city. Roads of Kolkata metropolitan area. And the objectives revolves around to develop a model for identification of accident black spot road using a combination of ANN and two types of classical approach, accident frequency and accident severity, to identify the road segment recognized as black spot using the combining classification and fuzzy sequence clustering method that I will discuss later, and to identify the road segment categorized in the medium possibility range that will elevate a highly vulnerable group. Basically, it's a most important point. Basically, whenever we are classifying the data, it's a highly vulnerable group, it's a black spot or not black spot. But some points are there that is not correctly recognized. Maybe this time that data are correctly not recognized as a black spot, but at near future that may be elevated. That may be the highly vulnerable segment of that area. Okay. Now, need for study. Basically, I have done the extensive literature survey.
Short of times will come.
Okay. Basically, I have collecting traffic data, accident-related data, geographic data for certain roads, and developing accident database. I have calculated the missing values. Basically, basically for the data collection part, there are so many missing values. Basically, always traffic data is not available. Live accident data is not available. And then selecting features of variable using feature selection method, developing accident prediction model, and from that model, after analyzing data using this model, I have identified black spot on the road segment using the accident prediction model and the black spot identification model. This is my study area. And for this research, I have taken 4 features, that is spot speed, number of left and right turn signal, peak hour factor, and the road width. And this is the classical approach. One is accident frequency, and you can see here I have taken the basically the length of the road segment as a value, and I have calculated a critical value if the output is greater than the critical value, that comes under the black spot, and if it is lesser than the critical value, that comes under the not black spot area. Similar, I have computed it. I have just shown the 44 segments here, and somewhere you can see that was not black spot but identified as a black spot in green color. You can see that was identified previously. Actually, that was not black spot, but after the classification, that is black spot. And just for 44 data, the incorrect prediction was only 1, and the prediction accuracy is very high. And similarly, I am using the accident severity, and severity basically number of fatalities, number of injuries for a particular segment. I have collected the data and number of damaged vehicles, and I have calculated the severity. If it is greater than the severity of that segment, then that comes under the black spot. Otherwise, that if it is lesser than the severity the value, that comes under the not black spot. And I have calculated the severity, that is 29.43, and whenever it is greater than the 29.43, that is comes under the black spot predicted. So you can see the green color that was not in the black spot, but now it comes under the black spot. But here using this method, the number of correct prediction 41 and the incorrect prediction is 3, and the prediction accuracy is 93.1 for 44 segments. But I have taken up large segments. Now I have just classified into two categories, black spot and not black spot. But now I'm basically I have used here, I have employed here a new a method, that is fuzzy Siemens clustering, to identify the medium vulnerability group. High vulnerability group, low, and the medium vulnerability group. And that's I am using fuzzy Siemens clustering, and where you can see the possibility of considered as black spot. For lower group, the possibility is 0.0 for segment 1, and medium possibility is 0.02, and higher is 0.98. So it is comes under the black spot. And you can see when the segment number 3, you can see the low 0.04, medium 0.85, and higher is the 0.11. So it comes under the medium vulnerable group. So we have to basically take the precautionary measure of the high vulnerability group. Of course, we will consider, because it's a high vulnerable group, so it's a black spot. We will some precautionary measure has been taken, but medium vulnerability group, we have to take care of that. And the conclusion of my combination of conventional method and fuzzy Siemens clustering has been employed to identify the black spot or highly vulnerable road segment and low and road segment presently identified in medium possibility range that are expected to promote it to a highly vulnerable group in the near future. And this medium vulnerable segment in any road, already I have told you, the road needs special attention for future safety, and good accuracy is ensured if combination of computational and the classical approach are being applied, and newly proposed method for black spot identification is selected suitable method based on the prediction accuracy and the measuring errors. And the technique applied in this paper may find its applicability to other urban roads having similar constraints and the problems. And the acknowledgement, basically I have used the live data from Kolkata Traffic Police Department, and references.
Yeah. Mail. Gmail.
Only references.
References. These are the references. Basically, so many references are there. That's why.
I would now like to invite the next presenter for the paper titled A Comprehensive Analysis of Various Cyber Attacks Dataset Used for Intrusion Detection System.
It was there, it was not there. It was not in the folder. Have you seen it, Chika?
Yes, sir.
Shabdachan is there, no? This one. Yes, yeah, I think this one. इसको डाउनलोड कर दो हाँ डाउनलोड कर दो District 17 slides are there. You just use 5-10 minutes only, okay? Deepshika 141. ऑनलाइन है स्टार्ट करते करते हम लोग बता रहे हैं कम्युनिकेट कर रहे हैं
Good afternoon, everyone. I am Deepshika Kumari, currently doing PhD from BIT Meshra. I am working in the field of network security, and my research area is intrusion detection system. So I am here to present on my paper title, a comprehensive analysis of various cyber attack data sets used for intrusion detection system. These are the contents. So let's start with the introduction part. So intrusion detection system monitor the network traffic.
Yeah, sure, why not? You can do it.
So intrusion detection system is a tool or a system which is used to monitor the network traffic and system from unauthorized access. IDS can detect and deal with insider attack and outsider attack both. To execute the process of IDS, we need to first collect the data, then classification, then reduction, then response. So there are two types of IDS. First is host based and second one is network based. Host based mainly monitor in single devices, and network based basically monitor connected devices to the internet. Host based is OS dependent and network based is OS independent. So coming to the next slide, data sets. So I have collected various data sets for intrusion detection system, which will be used for further researches from past to the latest data set. So the number one data set is DARPA, second KDD Cup 99, then NSL KDD, then Kaito. First one is Linux based and second one is Windows based. Then UNSW NB15, then CSC CIDS dataset, then BlueFlow, then NF UQ NIDS, then UNR IDD datasets. So coming to the methodology part, so I have taken UNSW 15 dataset and trained the 4 machine learning models. That is, first one is artificial neural network, second one is k-nearest neighbor, fourth one is naive Bayes, fourth one is logistic regression. So what is UNSW NB15 dataset? So it has total 49 features which are subdivided into 6 groups. That first one is basic features, flow features, time features, content features, additional generated features, then labeled features. So for my methodology part, I have taken best 20 features out of 49 features to train the machine learning models. So coming to result and discussion part, to execute the machine learning models, I have taken different ranking matrices, that is F1 score, precision, recall, and the accuracy. So mainly I'm focused on accuracy. So I have taken binary classifier and multi-class classifier to show the attacks, whether it is attacks or a normal. So in binary classifier, KNN has 95% of accuracy, ANN has 94.3% of accuracy, Neighbors has 81% of accuracy, logistic regression has 85% of accuracy, and in multi-class there are so many instances which are labeled from 0 to 9, and I have taken first normal and taken only one attacks from the above multi-class classifiers, that is generic, because generics have a large amount of instances. So in multi-class, KNN has 76% of accuracy, ANN has also has 76% of accuracy, Navies has 50% of accuracy, logistic regression has 68% of accuracy. And among this, KNN has the highest accuracy, that is 95% for binary and 76% for the multi-class. So coming to next slide, that is conclusion. I have discussed the intrusion detection system and machine learning. Various cyber attacks dataset are presented, and I have taken UNSW-NB15 dataset to train the 4 machine learning models, and KNN has the best accuracy among all the models. So the main advantage for this paper are for the researcher, which will be helpful for future work. Thank you.
We would now proceed further with the next offline paper and the last one for today, Enhancing Security in Blockchain-Based EHR Retrieval, a comparative analysis of block ciphers with a special emphasis on present 80.
ऑनलाइन वहीं पर कर देंगे, बेटर रहेगा ना। उसी स्क्रीन से आप लोग देख लेंगे, जिनको सुन रहे हैं, मैं वहाँ से बात कर रहा तो सुन नहीं दे रहा था, वही करेगा।
So good evening one and all present here. I am Saurabh Gupta and I feel honored to present our research titled Enhancing Security in Blockchain-Based EHR Retrieval, a comparative analysis of block cipher with special emphasis on present AD. My co-authors are Banshika Agrawal, Dr. Prashant Pranav and Dr. Shamama Anwar from the Department of Computer Science and Engineering at DIT Mesra. The work reported in this paper is sponsored by GenCare 2.0, Biotechnology Industry Research Assistant Council, Department of Biotechnology, Government of India. Moving forward, this will be the subsequent presentation outline. The integration of blockchain technology in the healthcare sector offers transformative possibilities for managing electronic health reports. However, ensuring the security and privacy of electronic health reports still remains a critical concern. The digitalization of healthcare reports underscores the urgent need of robust data privacy and security measures. EHR systems are highly targeted by cyber attacks, posing threats to patients' privacy and security. Encryption emerges as a fundamental tool to mitigate these risks and safeguarding patient information. Recent studies indicate that Present AT to provide robust encryption for healthcare data while minimizing the computational overhead. Present AT, renowned for its lightweight nature and efficiency, emerges as an ideal candidate for securing EHR in this context. Present AT is a lightweight symmetric block cipher with a various key lengths of 80 bits and 128 bits. The lightweight nature of Present enables it to be seamlessly integrated into resource-constrained environments, providing optimal balance between security and efficiency. So now let's have a quick go through around the algorithm of Present AT. The process starts with the plain text that needs to be encrypted. The plain text is initially combined with the initial key. This step involves bitwise XOR operation between plain text and the initial key. The resultant mix from the 8-round key is then passed through SBox layer, which replaces bits of the data to provide diffusion. After substitution, it is then passed through P layer, which rearranges the bits of the data to provide diffusion. In each, these two steps are repeated for multiple rounds, and each round the operations of substitution and permutation are applied, and the key is updated in every round using the key scheduling algorithms. After all the rounds have been completed, a final 8-round key operation is performed. The output of this step is the ciphertext, which is the encrypted form of plain text. To validate the performance of Present AT against AES and DES, we conducted extensive simulations encrypting simulated data. We examined encryption time and size of encrypted data to measure the efficiency and effectiveness, with our results indicating a clear advantage to Present AT. We analyzed and compared the performance of AES, DES and Present AT for the encrypting and decrypting files of various sizes. For each scenario, we executed the algorithms multiple times.
How many file sizes you have taken?
Sorry, ma'am?
How many file sizes you have taken?
Around 10 different file sizes.
10.
Yeah.
Like, for example?
Ma'am, as you can see in the graph, we have taken the length of the characters as different sizes.
Okay.
So we have taken 50 characters, 100 characters, 200 characters, 300, 400, subsequently like that. And we measured the execution time for encryption and decryption separately.
For all the three?
For all the three algorithms, yes. For each scenario, we executed the algorithms multiple times and recorded the average execution time to mitigate any possible outliers. Our empirical
How many times you have executed?
5 times.
5 times.
For each scenario, we executed
For
5
each.
times and then took an average. Our empirical analysis demonstrated that Present AT maintains consistent execution time across different file sizes, providing it suitability for lightweight applications. In contrast, both AES and DES showed increasing time complexity with larger files, suggesting potential challenges in lightweight applications. Our study provides valuable insights into the computational efficiency of these algorithms, with Present AT offering consistent performance, making it a strong candidate for lightweight applications. In contrast, AES and DES may struggle under resource-constrained environments, and Present AT stands out as an effective solution for securing EHR within blockchain-based healthcare systems. Finally, I would like to express my gratitude to my co-authors and collaborators for their invaluable contribution and insights. I would also like to thank the Department of Computer Science and Engineering at BIT Mesra for providing us with the necessary resources and support throughout the research. A special thanks to the BIRAC and IKP Knowledge Park for their financial support and belief in our work. Lastly, I would like to thank the organizers of ICMIA 2023 for giving us the opportunity to showcase our work. Thank you.
मैं बस कर रहा हूँ मैं चल रहा है कोड देखो वहाँ पे कोड है ना डेस्कटॉप में नहीं ऐसा देखो ICMIA गूगल मीट लिंक है ना ICMIA गूगल मीट देखो ना वहाँ पे लिंक फोर्थ फाइल नोटपैड फोर्थ फाइल से देखो सॉरी हाँ नोटपैड देखो एक नोटपैड है हाँ वो नीचे वाला टेक्निकल सेशन जो है ना नीचे वाला लिंक ले लो नीचे वाला वो नहीं अरे हाँ करो paper 130 are you there join करो हाँ हाँ आप लोग you can share you can share
Good evening, everyone.
Good evening.
Good evening, everyone.
Now we will be starting with the online sessions for today. The first paper for the online session is under the paper title Seed Clustering by Using Subspace Clustering Algorithm and Feature Selection Algorithm.
Okay. Good evening, everyone. I'm going to present the paper which is titled by Seed Clustering by Using the Subspace Clustering Algorithm and Feature Selection Algorithm. Okay. First of all, I am going to explain that the clustering task generally contains a lot of the attribute or features. In a particular clustering problem, generally all the attributes are not important. When a clustering task is used for data sets, it contains some attribute which leads to reduction in the computational time and provide the better result. Okay. Then the feature selection is used to obtain a feature subset that become most critical for the clustering or classification. Its interpretability is essential for various reasons, such as improving computational efficiency, increasing the performance of clustering for the classification. There is some problem related to the feature selection, which is explained as in the slide. Even after the application of feature selection algorithm, which is about to determine the relevant attributes, the cluster presented in the subset of attributes might not be found. It is generally due to the subset of relevant attributes shared by the member of one class, which may be dissimilar from the subset of the relevant attribute which is shared by some other class.
Ma'am, sorry to stop you, but I think there's some technical issue and your slides aren't proceeding. So could you end the slide share and restart it once again? Could you share your screen again?
Okay, ma'am. Okay, ma'am. I'll do it again. Okay, ma'am. No, the slide is shared.
Okay. Could you put it in full screen mode, please?
Okay, ma'am. Okay, this is Sean.
Okay, just a minute.
अभी एक मैसेज आया स्लाइड्स
Could you please,
Start.
yeah, you can start.
Okay, thank you, sir. Okay, sir.
Can you enable slideshow?
Yes, sir. I'm presenting my slides. It is.
Can you,
Could you please go to the slideshow option?
Okay, slideshow. Okay. Okay. Now it is okay. Okay, I'll just go ahead.
एप्लीकेशन शेयर करिए पीपीटी की एप्लीकेशन स्लाइड शो अलग एप्लीकेशन में ओपन होगी और वो प्रेजेंट नहीं हो पाएगी तो आज
Okay.
विंडो शेयर कर
can you please share your window?
फुल स्क्रीन शेयर करिए
Can you share your window?
Okay.
फुल स्क्रीन शेयर करिए
Full screen share.
पर्टिकुलर टैब
Please mention.
Yeah.
Okay.
स्क्रीन शेयर में इशू आ
It is share now.
Can you go to the next slide? We want to check.
Okay.
Yes. Now it's fine.
Yes, it's showing now.
अभी भी नहीं होगा
Okay. Sir, I have to run in this mode or I have to run the presentation mode?
The presentation will be better.
Okay. Okay, thank you, sir. Is this anything okay? Everything is okay at that time?
Can you press F5 on your keyboard?
Okay, sir. So I have a plan. I have pressed, sir.
Your slides are on slideshow right now.
Yes, sir. My slides are on the slideshow.
Okay, now you can continue.
Okay. I'm just explaining what is the problem of the feature selection. So that sometimes even after applying of the feature selection algorithm, which is used to determine the relevant attribute, the clusters present in the subset attribute might not be formed. This is because that the subset of relevant attribute which is shared by the one cluster may be dissimilar from the subset of relevant attributes shared by the some other cluster. Okay. Whereas the feature selection algorithm describes only a single set of relevant attributes in the overall aspect before the clustering, which is not good. Okay, next we are going to this. I'm going to apply the genetic algorithm for the feature selection process. Some test is spelling.
Go to next slide, please.
Yes, sir.
Next slide.
Okay. Okay. Next slide. Then I'm just going to explain what is the genetic algorithm because I
It's
have
not
applied-
showing here. Please go to next slide.
Okay. Next. Okay.
Hello. Hey, Kakshan, can you click the slideshow? Can you see the slideshow option in your ribbon?
Yes, sir.
Right now in your home, right? You can see there's a home and there's an underline.
Yes, sir.
Check the ribbon. Check the ribbon of the PowerPoint slide. You are not sharing your slides.
Okay. Okay, sir.
Can you see the home and there's a red
Okay.
underline? So just switch it to the slideshow.
Okay. So
Take
in
your
the
mouse. Take your mouse. Listen to me.
Okay.
Take your mouse. Go to the
Okay.
slideshow.
okay.
Go to the
Sir.
slideshow.
Sir, I'm just the slide show
Third
in
line.
the PPT format.
No, you are not in that mode. You are just it's not in your ribbon. It just follow the ribbon. File, home,
Yes.
insert, draw, design, transition,
Okay.
animations, and after that there is slideshow.
Okay.
Yes.
Home, insert, draw, design, transaction, animation.
Yes. Now click on slideshow. Yes. Now from beginning. Now click on from beginning.
Okay. Then the slideshow I have to
Click on the beginning.
from beginning. Yes.
Yes.
Okay, from beginning. Okay, sir. Now it is okay.
Not yet. I think the click has not.
Sir, please.
Proper. Just click on.
Sir, I'm saying that in the slideshow, from the top of the slideshow, then
Yes.
that
Now
from the
click on
beginning,
from current
from
slide.
beginning, from the current slide. Yes, sir. I'm just there. I've expressed the button from the beginning.
I don't know. Still, it's not showing. Okay. Anyway, let's continue then.
Okay.
Can you just try once with Shift Enter? You will be able to see all the windows available. Press Shift Enter once.
Okay.
And then you click to the presentation. It will be visible. Shift Enter in your system.
Okay.
Can you see all the available windows?
Okay.
Can you see all the windows? Select the one.
Yes. Windows, yes, ma'am.
Yeah. Now you
I'm repeating. I'm doing it again. I've sent, ma'am, in the windows, I'm going to PowerPoint presentation. Then I'm sharing that. Okay. Then in the presentation form, I'm going to the slideshow. Then from the beginning, I've expressed the beginning, and when I'm expressing from the beginning, then the slide is.
You have to press Shift Enter.
Okay.
Okay, I think there is some issues. Just please
Okay, let it be
continue. Yeah.
continue here.
Okay, some I think issues there. Please, Kakasa, just continue your slide.
You please continue now.
Yeah.
Okay, sir. Okay, thank you, everyone. Okay. Then I have applied the genetic algorithm in the feature selection process. Okay. In the genetic algorithm, we have, in the first of all, in the genetic algorithm, we have created a complete set of individuals. Okay. If there is n features are presented in the data set, then there's a 2 to the power n minus 1 individual are presented in the initial population. Next is the for the fitness assignment for measuring the fitness of the individual. We have used the fitness assignment. Usually, I'm using the correlation coefficient, whose formula is given here. The larger value of the correlation means that the corresponding individual is the more fittest for the process. I have shown the formula of that. And next time, using the Pearson correlation coefficient for finding the correlation between the attribute and the classes. In the figure, also I have drawn that the Pearson correlation coefficient for the classes and other attribute correlation between the. I have 7 features, which is name is area, parameter, compactness, length of the kernel, width of the kernel, asymmetric coefficient, length of the kernel group. I have used the C data set, which have the 3 classes and which have the 7 attributes. Okay. Then the attributes name is the area, parameter, compactness, length of the kernel, width of the kernel, asymmetric coefficient, and length of the kernel group. Okay. Then in the figure, I'm showing the Wilson correlation coefficient between the one features and the other features. For example, I'm showing the correlation between the parameter and other attribute, correlation between the compactness and other attribute, and so on. In this way, I have shown the correlation between the every attributes. Next, I have applied. When going to apply the genetic algorithm for the feature selection, first of all, we have to perform the selection operation. For the selection operation, we have to choose the chromosome from the population to become parents and produce the new offspring. I have used the roulette wheel selection strategy for selecting an individual for the further process. When we have performed the selection operation, then we have to perform the crossover operation. In this paper, I have applied single point crossover with the probability 0.7. In the crossover operation, a single divisor shows by n bit string. To perform a single byte crossover operation, a crossover bit positions C is chosen from the first father, and remaining n minus C bits are chosen from the mother. For the second child, we choose the first C bit from the mother and remaining n minus C bit from the father. And after performing the crossover operation, we have to perform the mutuation operation. Mutuation operation just applied after the crossover operation. It allows the random changes in the sum characteristic of the solution. When a mutuation is applied in a binary encoding technique, a bit is modified from the current value to the opposite value. In this work, we have applied the mutuation probability, which is 0.5, is used in this experiment. When we have applied the genetic algorithm with the help of feature selection, we get the features which get a single set of features. Then we are going to apply the clustering algorithm on that. In the next, we are going to apply the subspace clustering algorithm. Subspace clustering algorithm basically permit the user to interpret the idea that not every cluster in the dataset is in the same set of the dimension. Same set of dimension. There are many potential applications where subspace clustering can be used to help to discover the pattern which is ignored by the contemporary conventional clustering algorithms. Subspace clustering algorithm generate the clusters which are presented in the various different subspaces that could be challenging for analysis. The proposed algorithm not only diagnose the non-reductant subspace cluster but also describe the every cluster with the minimal number of the attributes. We have applied the COSA algorithm, clustering on the subset attribute, namely clustering on the subset of attribute. It is an optimization problem. At the beginning of the algorithm, equal weights are assigned to every dimension of the feature space. In the further iteration, a traditional clustering algorithm such as the KNN or KMNC is used to put the data object in the cluster by using the current weights. With the goal of minimizing the objective function based on the clustering result, weight and update accordingly. The algorithm continues keep abstract abist of the cluster and the weight of every dimension until the weight is stabilized. This algorithm have the key advantage that it enhances the weight of the dimension within a cluster subspace and reduce the weight of the dimension outside the space with the interaction. The algorithm places higher weights on the dimension with the minimum diversity in every group, and the parameter lambda is used for managing the increasing degree. The parameter ranges from parameter lambda is ranging from 0 to infinity. Next, I have shown the
Come to your conclusion part. You conclude now.
Ma'am, I'm not able to listen.
Conclude your work.
Okay. Ma'am, basically in this paper, GFS and COSA algorithm have been introduced and lies for the high dimensional data set. The COSA algorithm divides the full dimensional feature space in partially overlapped feature space, okay? And GFS used a genetic algorithm for searching if it's significant attribute by strength of the natural arrangement. When we have applied the COSA algorithm, we find that the dispersion of the attributes for the first cluster, second cluster, and third cluster. From the dispersion, we have selected the attributes which are important for each cluster, and by the when we have used the GFS clustering, we have find a single set of features. Then we have applied the clustering algorithm on that. After running the clustering algorithm on both subspace and feature subspace feature subspace by using the GA, we have found out that the subspace clustering gives the more better result than the feature selection process. For determining which is better, we have used three validity measures: sum of squared error, SSE, WGA, BAD within group, average distance, BGD between group distance. And by these three validity measures, we have found that the COSA subspace clustering is give better result than the feature selection algorithms. This is the conclusion.
Okay.
Thank you.
Any question, audience? Okay, you can
leave now.
Okay, thank you.
Now we would proceed with our next paper. The topic and title for this paper is Implementation of Customer Segmentation Using Machine Learning. Ma'am, could you please present your paper?
Is it visible?
Yes, it is visible.
Ask her to change between slides.
Can you try changing the slides once?
Yeah, sure. Is it changing? Can you see it?
No, actually it's not changing.
Okay.
Okay, now.
No, wait. Can I share my full screen?
Yeah,
Yes, of
please.
course.
Please share on full screen.
Yes, it is absolutely visible. You can continue with your presentation now.
Okay. Is my slide changing?
Yes, it's working perfectly.
Okay. Good evening, everyone. I am Sunika Kumari, and I am here to present on the topic implementation of customer segmentation using machine learning. Today, we are diving into the fundamental aspect of business strategy, which is known as customer segmentation. So, the question arises, what is customer segmentation? Customer segmentation is a process by which companies divide their customers into different groups according to their needs and preferences and choices, etc. Customer segmentation is the key in unlocking deeper insights into customer base, allowing companies to tailor their strategies for the maximum impact for their businesses and for the customers. There are various types of segmentation of customer data, and each type shares the new aspect of customer behavior. The most common types of customer segmentation are demographic segmentation. Demographic segmentation based on the demographic data of the customer such as age, gender, family size, income. Psychographic segmentation is mainly based on the personality, ideology, attitude of the customer, how they purchase in the marketplace or in the store. Geographic segmentation is based on the geographic location of a customer, like in hilly region, people mostly like to buy the more warmer clothes than the others. Last one is behavioral segmentation. It is basically based on the behavioral pattern of the customers, like what they like to prefer, like how much money do they spend on some purchases. So why do we need customer segmentation? That's a very good question that why we need customer segmentation process. So some of the points which highlights are digital era dynamics. In today's landscape, business are confronted with an escalating demand of comprehensive customer data for enhancing their experiences, how they would perform explicitly. The second is enhancing customer experience. It emerges as an important tool in the area of business seeking to elevate their for their customer experiences by systematically categorizing customer based on their unique characteristics. Second, the third part is data-driven decision making. By basing strategies on empirical customer data, business can enhance their strategies, planning, and cultivate more informed and responsible and optimal approaches. Precision on targeting. The targeted approach not only optimizes marketing effort but also enhances overall efficiency and resource allocation. Competitive advantage. A sophisticated understanding of customer segments provide a business with distinctive competitive advantage. Now, customer segmentation could be a compulsory task as we are provided with huge number of data set. Machine learning is one of the options that help us to simply we can segment for simple simplification. For the methodology, I have used RFM analysis,
outlays and scaling of RFM analyzed data, and then applying it k-means clustering and then data visualization. First, what is RFM analysis? RFM analysis stands for recency, frequency, and monetary value. It is a method used in customer segmentation based on purchasing behavior of the customer. In this, I have grouped the data based on the demographic segmentation plus behavioral segmentation. First one is on the basis of age, and the second one basis of the outcome analysis, which is a behavioral segmentation. First is recency. How recently a customer has visited the store of a certain age group. Second, the frequency. What would be the frequency of different age group would be visiting the store? And the third one is monetary. How much revenue does a business collect from the different age groups? For example, in a day, if a company wants IF group in a such a way that how recent certain age group of customer of certain age group recently visit a store, what would the frequency within a week, and how much monetary value the store gain from that? Now, after RFM analysis, there comes the outlining and scaling of data. Outliers are basically the points that considerably differ from the majority of the observation in the statistics. They may lead to the deviation of the data but may not predict the appropriate result. Eliminating them helps us for precise data analysis. I have removed the outliers with the help of interquartile range. Next process is the scaling of data. Altering the data set property so that they can lie on the similar scale. The process, it can be done by the standardization of data by Z-score normalization, normalizing all the data sets such as revenue, monetary, and frequency so that each scale would come under cluster properly and would not deviate the data. The last step, the next step is k-means clustering. It is a technique of clustering of data points that are used by unsupervised machine learning. The minimizing the various means the method iteratively separates the data points into a number of clusters. The question arises, how many clusters do we need? Maybe we need one cluster, two cluster, or the number of data points at present. So to tackle that problem, I have used the LO method. LO method is a used technique to identify the number of clusters in a data set. The LO method plots the region where SST sub-square of distance decreases slow down, indicating the performance of the model will not substantially improve by adding more clusters. For example, if I want to add only one cluster, there is no point of segmenting because all the customer data will lie only on the one plane. But by using the LO method, we have identified the ideal number of clusters. For here, my ideal number of clusters is 3. So how can I present that? With the help of data visualization. The process of presenting data in a visual or graphical manner for the purpose of understanding, analyzing, and communicating the pattern trends inside is known as data visualization. Here are 3 different types I have presented. First is cluster ID and revenue. Here you can see the 3 clusters I have presented. They are quite different from each other and they also provide the large variation among the data. The business houses can see the different types of clusters and estimate it, how they can use a segment and offer different offers to their customers. Summary. The customer segment summary. At last, I would like to conclude with the summary. The customer segmentation is distinguished different steps of customer groups. There are different types of customer segmentation: behavioral, demographic, geographic, and psychographic. Outcome analysis provides recency, frequency, and monetary value of the customers, removing outliers, eliminating significant deviation, and standardization numerical variables to a common scale for equal influence. K-means clustering to group K numbers of cluster based on their similarities. Data visualization provide an insightful how different customer of different age groups have been segmented based on their outcome values. Data visualization we can
Yes.
do the most.
This is your data visualization slides.
Figure 9, 10 and 11. Can you explain these figures?
Yeah, I can explain the
Yeah,
figures. There are three
please.
different figures. Each figure shows the different variation of the
What you have plotted on x-axis and y-axis?
There are in x-axis there are different cluster IDs. On the y-axis there are revenue based on how much revenue each axis has formed. If you see the
Revenue
second,
is
if you
related
see
to
the first
monetary.
one, the most number of customers fall under the most number of customers fall under the first one, the first cluster, and the second, and in the second, the next, and the least amount of cluster in the zero cluster, and also in the frequency form. The most frequently visited customer lies under the first cluster, the cluster number 1, and the cluster number 2 in the green palette, and the least in 0.
So this is related to RBM which you have told. RFM.
Yes.
Recency,
RFM
frequency and monetary.
and they are also based on the how much age of the specific age they have been, or specific age of customers have visited.
Figure 11.
Figure 11. Figure 11 shows the recency value. How recently each customer has visited. Then the first one shows, the blue box shows the most number of variation the customer has shows. The second, the first cluster, the second cluster shows the last one shows the least amount of clusters. The customer having fallen the recency growth.
Okay, fine. You can wind up now.
Okay, thank you, ma'am.
Bye.
Thank you. Now we will be proceeding with the last paper for today's conference. The title for this paper is Improved Defect Detection and Classification Method for Advanced IC Nodes by Using Slicing Aided Hyperinference with Refinement Strategy. Sir, I request you to kindly start your presentation.
Hello, can you see my slides?
So actually your screen is not properly visible right now. It's mirroring. The slides are not visible.
Okay, that's fine. Now can you see my screen?
Yes, sir, your screen is visible.
Okay. So the slides is visible, right?
Yes, sir.
Okay, thanks. So welcome to our research work on improved defect detection and classification method for advanced IC nodes by using slicing aided hyperinference with refinement strategy. I'd like to thank my colleagues from IMEC and University of Ghent. With their contribution, this research work was really possible. So today's overview of I'll give some of the brief introduction on the continuous scaling, introducing what new challenges, what is defect classification versus defect detection or localization. I'll highlight on our proposed methodology, some of the results and comparative analysis, what is the limitation and what far we can go ahead from this work, and finally the conclusion. Okay, so I already discussed this in my keynote, but still I'd like to repeat very quickly. So the continuous progression of Moore's law leads to the complications in patterning, because we are looking forward to go for advanced scaling beyond 2 nanometer node right now with Intel. So you can see the Intel's agenda of the roadmap for the next 10 years. We are right now in the sub 5 nanometer node, and we are looking in 10 years in the Armstrong level. So it is called 2 nanometer and beyond. Don't take it literally, but it has some different meaning. It has some industry version of the scaling nodes. Okay, but the main problem is with the increasing of this device complexity requires increased process control because we are expecting the yield to be errorless, right? Even 1 pixelite of the defect, like it is coming from the different process drift, can really impact the yield. So basically, we are trying to standardize it like 99.9999%, if not possible 100%. And in that domain, the accurate metrology and the data analysis is a key significant role to play, specifically in terms of defect inspection. Okay, so the patterning can be possible with 3 defined dimensions. One is a multi-patterning. Here, our ideas are for self-aligned double patterning, self-aligned quadruple patterning, and self-aligned octuple patterning. So that means one design can be decomposed into several masks, and then from that mask, we go from one layer to another layer and try to print the device in our silicon wafer as a 3D stack. So probably like in this domain of 2.5D or 3D SoC structures. Okay, next is the innovation in the tool. So right now we are using ASML UV tools, extreme ultraviolet tools, which is making possible of patterning beyond 7 nanometer. But right now we are also doing the research on high NA. So that means the possibility of increasing the numerical aperture of the lens so that it can make it possible to go beyond 2 nanometer. And another is it is related to the chemical property of the resist, how we can make patterning possible with the polymer, with the chemistry of the polymer, which is called directed self-assembly. Okay. But no matter what innovation we are taking into consideration, that is always give us the challenge of how we are taking those images and how we can nullify the noise and how we can do the defect inspection. So the challenge is ongoing. So we are talking, or we are in the paradigm of hybrid metrology, even for the defect inspection. So there definitely we are going to research what is the applicability of or the significance of AI. Okay, so now we can see that there's a picture. If we go from UV to high NA we have to reduce the resist thickness from 25 nanometers to 15 nanometer, and now we can see that it is not even possible for even the existing or well-known computer vision algorithms of the scripts to detect the defect in presence of this noise or in the presence of this behavior of the images. So that means the machine learning is not only the solution. The solution is how we can make this machine learning model advanced enough to cope up with these challenges. And also the challenge is not only on the signal to noise ratio or the pattern, but also in the patterning, we have the different complexity. So we are going from the 1D or 2D or the regular pattern to most irregular pattern. Like if I talk about VRAM or SRAM, then or the logic pattern, the pattern is also becoming more and more complex. Right? And so it is not even possible for a supervised machine learning to take these challenges. So we have to be innovative enough in the domain of machine learning as well. Okay, so here also, not only that, the third boundary is, because these are the stochastic events, because this is coming from the tool or the resist, or there are so many stochastic events, even the image in contrast is going to change. Right? So we have to tackle different aspects into one algorithm. So of course, we can imagine that the current state-of-the-art defect detection tools, based on optical or E-beam, they have certain limitations. Okay? And because they are mainly driven by the rule-based techniques. So rule-based technique means I have a script, I can maybe vary some of the parameters like Sobel operator, or you can say median filtering, Gaussian filtering. So it depends on choice of few parameters. But that parameter, it is a trial and error method to really calibrate those parameters, and which is humanly impossible. It cannot be done, because I can say what is the difference when, say, if I want to apply the thresholding, I know, okay, 120, if my range is from 0 to 255, I can definitely say that, okay, the middle point is 127. But if I have a floating point variation of the pixel intensity, say I'm talking about 127.99 and 127.5, they have also a great significance role to play for the defect inspection. And in that case, this gradient is not going to happen. No algorithm can detect this gradient change. Right? Okay. So Of course, like we have several research are available there in the community. They deploy the machine learning algorithms for the to prove the robustness of varying imaging conditions and patterns, and they are mostly working well. But still, there are some certain limitations. So this research contributes towards solving some of that constraint. So first, the contribution is we implemented Sahi slicing aided hyperinference to demonstrate the defect detection performance improvement, specifically for challenging nanoscale defect types, because all these defects are appearing in nanoscale. So we took two well-known popular YOLO algorithms or architecture variants with different configurations. We experimented with two different challenging semi-image datasets, scanning electron microscopic dataset. One is for line space, UV-based patterning, and one is the hexagonal contact hole arrays, which is based on directed cell assembly patterning. Okay, next, we demonstrated the Sahi-based framework resulted in flawless detection rates on a novel test dataset. What is novel test dataset? That means we have a very different, not very different, but say, I'll show you the data slides, a very different distribution from the trained dataset. We didn't want to retrain the model. We took the dataset as a separate test distribution, and we tried to experiment that whether our proposed methodology can hold that constraint or not. And we have seen that without retraining, our proposed mechanism can detect those defects as well where the previous YOLO models are failing, the trained YOLO models are failing. Okay. Finally, we propose a new strategy appended to the existing baseline of Sahi framework from the authors to refine the model predictions towards eliminating false positive predictions. Okay. So we're trying to breaking the barrier where we are trying to unraveling the bottlenecks of the ML towards advancing semiconductor defect inference supremacy. What is that? Though the machine learning models in any domain is working fine, but when it is coming in terms of high volume manufacturing or when it is coming towards a real world application, we have seen that the reliability and the adaptability of machine learning models are always questionable. It always fails from the theory to the practical implication. Okay, so factors to be considered what? So of course we have to remember that if we are talking about the supervised learning, the machine learning models are can learn from the data sets labeled by us, or the human experts, right? But there is a challenge. What is the challenge? That if I'm talking about a real world data set, the catastrophic failure are always negligible. Say, we cannot expect a car to be collided each and every day, right? So the collision is a stochastic event. It can appear 1 out of 1,000 events, right? But now if I want to build a model based on this data, I have to think in mind, so the question is not whether we can train the machine learning model on that data set or not. The question is how we can handle the reality of the data imbalance or the class imbalance problem. So that is exactly what we have done here. Next is the quality of labels is important. Why? Because there is always an ambiguity in defining precise pixel extent, what is the foreground and the background for some defect classes or instances. Say for example here. So we're seeing that for the unlabeled image, we have a close patch. So this is a real close patch defect. But if when we give this data to 3 labelers anonymously, so labeler A has labeled this way, labeler B has labeled, you can see that most precisely, which one of the instances are not yet labeled by labeler A or labeler C, and labeler C has labeled it completely different way. So he is seeing multiple defects, which is in his vision or in his version is correct. But the thing is that now, if I am thinking about putting this data set into the model, so we of course now the model is going to fail because the model is not learning the variance because it is seeing a variation of the labeling. So it may be confused. So we are making the model biased. Right? So we have here the missing labels as well as defects in the multiple defects is completely mislabeled. Okay, because there was no defect from the expert. He never defined this class of multiple defect. It should be either close patch, it should be partially closed, or it should be missing. So in this work, we have investigated this use of this problem using slicing-aided hyperinference for improving the current techniques. Okay, for a quick summary, what is classification versus detection? So classification is very easy task. I am showing an image. and the model has to predict only whether what class it is seeing, is a cat or dog. So in case, what is the defect it is seeing, right? For detection is one step further. So the challenge is here not only classify, the challenge is how to deal with the background, because for any object detection scenario, we have to deal with the class imbalance problem. So here the class imbalance problem is not how many images I have for cat and how many images I have for dog. Here the class imbalance is the challenge or the contrast between the foreground and background. So what is the foreground and background? Foreground is within the bounding box what the model is seeing, and anything outside the bounding box is considered as background. So in that case, so you can see that in this same image, and these defects are appearing in the nanoscale range. So we can imagine that how the background is overpowering the foreground limitation. So that is a great deal of challenge we have to tackle. Okay. So what is the experimental data set? So we have collected only 250 same images because we don't want to use synthetic data set. We want to go for the high volume manufacturing stochastic event defect detection. So we have collected what the data set was coming from a real waveform. It's 250 and it has 3 partitions as missing hole, partially closed hole and closed patch. We can see the data distribution here. We have used 174 for training, for validation 34 and for test only 42. Okay. So, and you can see the glimpse of the defects appearing. So partially closed hole, missing hole is quite similar to partially closed hole, but it is completely closed, and we have closed patch. And inside the closed patch also you can see in the neighborhood or in the vicinity there the partially closed hole and missing hole is still existing. Right? And then the research team has given us a very new test data set. As you can see, this is considered as missing holes, but now it is 2 or 3 in the vicinity, and here the model was failing. I'll show you later. So the challenge was how without training of this, because I don't need to train because this is a missing hole. The model was failing considering it as maybe close to close patch or something like that. So that we have to investigate. Okay. Second data set, we took the line space. We considered 1,324 same image of line space after developer inspection, that is after the development of the pattern into the silicon wafer, and we have 5 different defect types. Again, the class imbalance problem exists, but we have to deal with that problem because we don't want to use any synthetic data set. And this is also some examples of the different defect types: line collapse, breach, probability of gap. So probability of gap is where your line is going to break, maybe in next process there, and micro breach. Okay. So what is the proposed methodology? So we started with a very conventional way of training and inference. We used 2 different models, YOLO V8 and YOLO V5, and the different architecture variants as nano, medium, extra large or large, whatever it was available. Before applying SAHI, so we took the inference and we considered to use 2 different variants from the 2 different models. One is YOLO V8M, medium, and YOLO V5X.
So we are running short of time. Can you wind up, please?
Yeah, sure. So, with the SAHI, what we did, we generally sliced it in an adaptive way and then resized it back to the original image size. So SAHI, what is the benefit of SAHI? That without using or changing model quite a few times, SAHI can be plugged in any existing pipeline, and you can do the defect inspection. So what we did is we fine-tuned the training strategy with the same model with the different slicing technique of size of 128, 256, or 512 with an overlap ratio starting from 0.5. And we fine-tuned the model one more time, and we have improved the defect inspection here. Now the next one was really challenging for us. As you can see that if the model was detecting at the edge, it was appearing as a false positive. So we invented a new way to refine this strategy to remove the false positive detection. So here the strategy is, if the model is detecting any of the defect instances at the edge, we are going to reslice it back so that the event of the defect can happen at least in the central or somewhat location at the central, and then we are calibrating the IOU index based on the confidence score. And if the confidence score is not matching with the previous one, it will be discarded as false positive, and if it is matching with the previous one, it will be considered as true positive. So based on that, For the line space, now we can see that how we have improved the detection. This was the human annotation. This was without Sahi, so I can see that some of the different instances which human annotated, that was missed by the model, the trained model. And with Sahi, not only we have complied with the human annotation, but we are detecting something extra. Okay, and the figure is shown here. For the DSA defectivity, we can see the same thing. This is the human annotation. We can see that model is complying, but it has missed one instance, as well as the human has missed one instance. With Sahi, we can correctly detect that occurrence even in this challenging scenario. And we can see the data set. But each and every instance, we can see the false positive has been increased. And that is what I have explained with the refinement strategy. So this is the test image. Now, which was not annotated at all, which was not trained at all. So without Sahi, now we can see that it was getting as close match with the trained model. But with the implementation of our strategy, we can correctly detect without training the actual occurrence of the defect. And we can see that as per the metric, we have kept the true positive constant, but we have successfully reduced the false positive for gap 100%, for P-gap 83.3%, and for partially closed hole 95%. For missing hole, it actually doesn't exist. Okay. So then we make a comparison analysis for the precision and the recall, and we can see that not only we have classified them well, but we are also improving the biasness of the human annotation, that we can replace a human annotation by the annotation through Sahi, and you can see that with the two different variants, how the Sahi based model is improving for two different instances, the average precision and the average recall figure. What is the limitation in the future work? Yeah, definitely. So first of all, significant number of missed or unannotated different instances are existing in the training data. The future work is retraining the object detector models with the annotated set as well as the Sahi-based inference based annotations to improve the labeling rules. We can think of this strategy as an alternative to the data augmentation strategy, which may result in better training annotations that is going to be investigated in future work, and assembling of the different ML models and fine-tuning Sahi parameters, such as slice overlap or the area threshold defined requirement. So finally, the conclusion in this research work, the model which we are proposing has been applied to the semiconductor defect inspection task. On both datasets, we have seen 2 times improvement on the true positive predictions, whereas for the false positive prediction, we have mitigated the problem with a significant metric. Finally, we formulated an extension of the Sahi framework where a new refinement strategy has been developed, which demonstrates for the false positive predictions on the partially closed hole, the defect is going down from 40 to 2 only, without any significant decreases of the true positive predictions. Thank you.
Okay, thank you.
Okay, I have one doubt. Bappa, you have used cumulative false positive and true positive.
Yes.
Yeah, so why should you go for this? Why should you use cumulative?
Okay, so the question is, we have questioned also the methodology of the human annotation. So when we are training the model based on the human annotator, we have shown that human is also error prone. They are missing some of the defect instances, right?
Okay.
So in that case also, if we are missing something to annotate, and the model is, say, during the training and the validation, the model is also predicting some of the instances which has not been labeled by a human, right?
Okay.
So in that case, that detection is also going to be false positive.
Okay.
Right? Okay. So we have to consider that as well as what the human has not been labeled yet, or what are the new possibilities of the defect for the defect instances has been created by the model. So if I accumulate these two domains of the paradigm, we have to consider false positive and false negative, because we have to justify that the false positive is not the real false positive, or the false negative is not the real false negative.
Okay. Yeah. Okay. Thank you very much.
Yeah.
Thank you, sir. Sir, I request you to kindly send us a copy of the presentation that you had presented to us today.
Okay, I can share the link because I tried to share the slides, but it's so voluminous that the link is not supporting to upload this slide. So maybe I can share with some OneDrive link.
Okay, sir, as you may prefer.
Yeah, okay.
Thank you, sir.
Yeah, no problem.
conclude the session.
Okay, so now we'll be concluding this session and we shall proceed with the certificate distribution. Parthu sir, end the meeting.
Ma'am, please. बोल दो ना उनको that we will be giving a certificate on the nominal.
Ma'am, please. Mrs. Sonima Tikka, ma'am. अभिषेक कुमार कैसे मिस स्वागता घोष मैम डॉक्टर अमिता सरकार दीपशिका कुमारी मिस्टर सौरभ गुप्ता
Yes. Alok